I'm Brigham Larson with Brigham Larson Pianos. Pin blocks on uprights are a major, major hassle, and so the solution in the past has generally been to, well, do anything to avoid replacing it. In a grand piano, it's a lot more straightforward. Yeah, let's go over here, and you can see here's a Steinway D, couple Steinway Ds right now that we're restoring actually, but in a grand piano, it's much more straightforward. A Steinway, they actually happen to glue it to the stretcher, so that's a little bit more of a hassle, but for the most part, it's just fastened at the front, or on the left side and on the right side. Most manufacturers don't glue it like Steinway does, but even still, even a Steinway pin block is a lot easier than an upright pin block. So generally, we avoid replacing pin blocks at all costs. So like here's one, you can see, I mean, everything is just completely glued in. Have a look up here, you know, removing, so the pin block goes back to here. You can see that seam where the pin block goes. So you can imagine replacing that would be an absolute nightmare to remove it from all of these back posts, all of these supporting pieces here, taking off the sides, everything, getting all that off, putting on a new pin block, fitting it just right. Total nightmare. And so other solutions, we've come up with other solutions in the past, and they've worked just fine, but we're trying a new innovative solution with a CNC machine right now. So here is one that is a good test piano, and I'm feeling really good about this. Have a look right here. The cracking in here is very heavy. The pins were going in and out on their own with just like finger movement in and out. So that tells me, I'm wondering if maybe the pin block is not a multi-laminate, but just a solid piece. And this piano being German piano, and from the 19th century, who knows what they were doing in Germany in the 19th century. They were definitely not using delignit, which is what we're going to be using on this. So what we're going to be doing, I'm going to show you the computer and the CNC machine. We're just going to cut out an exact shape. Actually, let's look at the base, because that's what I'm working on right now. We're going to cut out the exact shape around here with the CNC. It'll be very precise, and cut that out to the depth of 1.5 inches, which is the exact thickness that delignit comes in. And then it'll be actually 10 thousandths larger cut out. I mean, the CNC is just so precise. You can be precisely in the shape that you want it, only 10 thousandths larger. And so the pin block insert will be perfect. So let's go look at that. We'll glue it in, and the CNC machine will already have the holes all drilled and everything. So let's check this out. So the first step, can you see that okay? First step was to take a picture from as far away as possible and zoom in to avoid any kind of parallax. Put rulers so I know exactly the dimensions. I can dimension this picture very, very precisely to within, you know, 1,000th of an inch based on the ruler dimensions. And then I made a sketch of the pin block. Here's the sketch. There you can see, I'll turn the canvas off. So I made the sketch of all of the holes based on the holes in the picture. And then I actually slightly moved them, because you can tell in the sketch, let's pull up that, or in the canvas, that the holes are slightly askew. I mean, you know, if you look from this line of 4 to that line of 4 to that line of 4, you can tell it's done by hand. And things are, you know, basically in proper alignment, but not perfectly. That one obviously is, you know, sometimes they're a little bit to the left, sometimes they're a little bit to the right. All of these don't really line up. Not that it matters, it really truly doesn't. It's just because I guess now I can get it all perfectly lined. So you can see all these sketch lines there. Everything is just in a perfectly straight line rows of 4. And here's one more thing that is, I mean, I took it probably too far, further than it needs to be taken, but why not? Because this is fun. So, for example, I found out that this angle here off of 90 is 14.2 degrees, the angle of these 3. And then the angle of these 3 over here off of 90 is 29 degrees. And I took the difference between 14.2 and 29, divided that out into equal numbers, and then I have it fanning an exact, 2.1 degrees each row over, fans a little bit more, 2.1, 2.1, 2.1. So this one's 22.7, 24.8, 26.9, all the way to 29. So all of those are beautifully spaced. And then I've got the Pinblock perimeter. Everything is spaced to, let's see, what did I do? I can't remember exactly what the number was, but half an inch or so. I can't remember what I did. Oops. Anyway, got it all spaced from these lines out, and so the shape of the actual insert is equidistant around the holes, and that's going to be out of this wood here. That's delignit, extremely hard, far harder than what they were using then. The stock, let me pull that up actually. Let's finish that sketch. Close that sketch. Okay, here's the stock. That's this piece here. There's the Pinblock, and that's the 5 degree. We're going to drill all these holes at 5 degrees. 5 degrees up, and so that will be this piece right there, inserted right into the piano, and I think it's going to be a beautiful process.